Hello everyone, my name is Nikoya and this is the Yamaha FB-01 sound module. It's a 4-operator FM sound module made in the mid-80s or something like that. I think it's based on the DX21 or DX100 or something. It's a little FM sound chip and a microcontroller that listens to MIDI. So I'm using my MicroFreak as a MIDI controller right now and I got a speaker hooked up. So the issue with this one is that it is producing very little sound and a lot of hum. So if we turn the volume up, you can definitely hear that hum now. Probably can't hear the sound that it's making over top of that. Let me get the mic real close in there. So that combination of hum and a very low output gives us a lot of information about what's going wrong with this module here. So obviously the microcontroller is working, it's responding to MIDI. The sound chip is producing sound, but something in the output is not working quite right. So it's the analog circuitry you're going to be worried about. The hum tells us that either a lot of noise is getting into the signal path, or that the signal path is not driving the output hard enough to override that hum. Since the output is also very low, it's likely the latter, that we don't have enough signal to cancel out that hum and keep it from getting into the signal path. So let's power this off, get the case off, and we'll have a look inside. All right, we've got the lid off now. We can see inside here. Power comes in the back here, goes through the transformer and a linear power supply with 3 5-volt regulators. One of them is -5. One of them is for the digital circuitry, one of them is +5 for minus and plus are for the analog circuitry down in the corner here. Got a microcontroller here, we got the sound chip right here, we got some RAM and some logic and everything else. So we want to concentrate in this area here. And the power comes in here, the red and the black here are for the digital, the green and the orange and the gray are the plus and minus 5-volt for the analog circuitry here. So if I plug this back in and turn it on, I can go ahead and go in here and probe between the digital ground and the plus 5-volt digital, and I will see it's about 5.1 volts on my meter. I'll put the the negative lead here on the analog ground. I'll check the orange and we have 5.1 volts. I'll check the green and we have about minus 87 millivolts. So that is telling us that our analog circuitry is not getting the voltage it needs. So that could be either an output problem, outputting from the regulator linear power supply here, or it could be an input problem here where we have some sort of short circuit pulling that power rail down to ground. So we'll switch this off here for a moment. We'll unplug this connector, and now switch this back on, and we will probe between the analog ground and the minus 5 volts, and we see that we have negative 5.08 volts. So that tells us that the power supply is at least trying to make 5 volts here, the minus 5-volt rail, but it is not putting out sufficient current for whatever is happening over here. And that either means that the regulator is partially roasted, which, spoiler alert, it's not, or it means that something is happening in this area. So if we were going to try to look for a short circuit, one of the things we might want to do is use a thermal camera. And I will show you a thermal camera picture that shows that this capacitor here, C25, is getting unusually warm. And so when we see a component that's warm in a short circuit scenario, what that means is that in that short circuit, that is the component with the highest resistance. And if we have a bunch of components in series, it's entirely possible that some other component is at fault for the short circuit scenario, and it's only going through the other component that's a higher resistance and heating it up because of that other fault. In this case, this capacitor is going between the minus 5 volts and the analog ground, so it is obviously our prime candidate. However, I'd like to show you another way to verify where the short circuit may be. So I'm going to use an LCR meter for that, like this. So let me get set up for that. I'm going to pull the board out and we will show how that works. Now, unfortunately, someone stripped the head out of this screw, so I had to cut a new one into it. So it is now a flathead screw, or a flat blade slotted screw. So we'll just have to live with that. Someone else's carelessness damaged this equipment. Okay, so we got the board out now. It is free of the chassis. And again, we are looking in this area here, and specifically around C25, which is on the -5 volt rail. While I'm in here, I'm also going to check the battery. It looks like it's original and a little bit crusty, so it's probably dead. So I want to just check that really quickly. So that's these two leads right here. And we are looking at, 3.3 volts. Well, I guess not. So this battery that's been in here since 1987 is apparently good, still good. In fact, that is 1986-07. So yeah, good job, Maxell. You make apparently good batteries. Anyway, back on track. Okay, so I have my LCR meter in DC resistance mode, and we're going to go across the power -5 volt input here to the board. And we can see we have 0.17 ohms. Now this is ohm range is very difficult to measure with a regular multimeter. The LCR meters are specifically set up to do a 4-wire measurement, so all of the resistance in the cable is taken account of by the way it's set up. So it was 0.17 here at the input. 0.14, I guess. 0.16, okay. So it's settling around 0.16, 0.17. Across this capacitor here that we are suspect of, come on, let's get the reading. We have 0.14, so that's lower. We'll go across this neighboring capacitor right here. That's 0.31, so a little high, 0.23, 0.16. So we see we're a little bit higher again. If we go down, so we follow the trace over to here, there is a resistor here, and the one next to it is connected to ground on this side. And so if I connect across there, we're again seeing a higher reading. So our lowest reading is here, and the traces between here are adding just a little bit of extra resistance that we can measure on our LCR meter. So that's another pretty cool way to narrow down which component is defective. So if you're wondering why this looks a little bit different here, I actually cleaned off some of the flux from the board because I've already taken this capacitor out and double checked it. Speaking of taking the capacitor out, let's do that next. So I'll bring the LCR meter back in here for a second, and we can see that this capacitor is measuring only as a series resistance of 0.142 ohms, and so it is going in the trash. So that was a 220 microfarad 16 volt. I have a same physical size 330 microfarad 25 volt. It will do just fine for this purpose. So we'll go ahead and install this. All right, so if it wasn't a different color, you'd never know I was in here. So this should be all good now. Let's get this back together and we will see if it makes noise. Okay, we're all back together. We're all hooked up and powered on. So we are on the brass preset, I think it was. Let me see. Instrument select. No. Voice select. Brass preset, apparently. Anyway, we're all hooked up. If I turn up the volume on my speaker here, that is all the way up, and I hear nothing. So we'll turn that back down, and we will... We will call that fixed. So, hope you enjoyed that video, and I will see you on the next one.